So, what do we know about the curvature of the Earth? Well, when you start asking a few questions, not much it seems. There's a lot of photos from planes or balloons showing curvature, some showing not. Could be a little curve here, very hard to say. But you never know what sort of camera's used or lenses used on the cameras. The fisheye lens makes everything look curved, even when we look with our own eyes it's flat. So it's sort of hard to tell without knowing what lenses are used and whatnot. This one here a bit further away, it's definitely showing a curvature. Definitely. But is it real? It's it must be inside the atmosphere because that's a mountain top there by the look of it. And here, all I can imagine what it is a mountain top somewhere, and the light there looks quite right, angling at the sun. But is it the right angle for 93 million miles or 149 million kilometres? I'm not sure. Then again, you don't know what sort of lens was used. So it's sort of hard to say. Look, there you go, there it is. The whole Earth. Must be round, right? Well, is this photo real? There's not one satellite around anywhere. Not one satellite, not one bit of space junk. We're further out than the International Space Station. It's not here. Must be on the other side of this sphere. But there's not one star. Doesn't take into account for that. There's not one star in the whole sky. So I think this is a computer image, even with the details and whatnot. There's you would have to see some stars once you're outside the atmosphere. But this is how we see it. Little hill, little valley, or over water, dead flat. Dead flat. Not a curve there. 3 months ago when I heard there was a flat earth movement, at first I laughed, but it wasn't right of me. I mean, science is all about keeping an open mind and recording your own results. And so I thought that's what I'll try and do. I thought there must have been some research done into the curvature of the Earth. And when you look into it, this is it. Heap of gibberish maths. Triangles, Pythagoras' theorem, squares. We're measuring a circle with squares and triangles. It all seems a bit gibberish to me to start with, but anyway, they get a figure of 8 inches in every mile, so 7.98 inches in every mile. Say 8 inches in the mile. Could that be right? Well, they say they can prove it and measure it on Earth. Well, it would be hard to do on land. On water, I'd be quite interested in this, because if you just do the basic math of it, 8 inches in every mile, 25,000 miles circumference, you go the whole 25,000 miles, you times it by 8 inches, you get 200,000 inches you've gone down. 200,000 inches. And I think just over 63,000 inches to the mile, I'm pretty sure it works out at around 3.16 miles. That's not a globe. The whole width or length of the Earth, 25,000 miles only goes down 3.16 miles. So we're not a ball that's one. How can we be a sphere that's 3.16 miles deep and 24,900 something wide? It's on the axis, like 3.1 miles on the x-axis and 24,900 and something on the y-axis. That's not a ball. doesn't make a ball. So I thought, can we work this out using circle maths rather than squares and triangles and Pythagoras' theory for triangles? Because it's supposed to be, we're told that it is a ball, a three-dimensional circle. So, what if we, well, to start with, just to get a few numbers, unfortunately I don't have the means to measure it myself. If I ever have the means, hopefully one day I will, but for now we'll have to go off someone else's numbers, and these are fairly widely accepted. I've read in a lot of places 40,008 kilometres around the poles and 40,075 kilometres around the equator, with a diameter of 12,756 kilometres at the equator and 12,700 at the poles. So there we've got some figures. So what if we look at it as a circle? Okay, well, we can work out the radius of circles. So the radius of the polar circumference will be 6,367 kilometres, roughly. Give or take a few kilometres. I'm happy. 63,367, and around the equator, 6,378 kilometres across there, from the centre of the Earth. From the centre of the Earth. So, if we were treading water, we'll use the water so there's no hills or valleys. If you were treading water right here, and you swam 10,000, I'll go into that too, 40,000 kilometres we're going to use. It's 40,008 around the poles, 40,075 around the equator. So it's not a perfect ball, but it's pretty close. It's pretty close to symmetry. 67 kilometres difference over 40,000. So it's not a great deal. Anyway, we're going to use 40,000 just for the simplicity of it. We're going to divide that by 4 to get this distance to walk around there like that. So if we were to walk from there to here, we're going to have walked across on this axis 63,078 kilometres, and then down on this axis 6,367 kilometres. So if you were to, swimming, because we're in the water, if you were to swim 10,000 kilometres, you're actually going to have gone down on the x-axis 6,367 kilometres in 10,000. Like, that's 63% drop. So, I mean, I know to average it out would be like a triangle rather than having that little bulge there. But nevertheless, that's the distance from there to there. If you were to go 10,000, so it's, and if you look at it, it's a very sort of even sort of dropping down, or it's a little bit flatter there and then starts. Does it get flatter here? No. It's a pretty symmetrical ball. We could spin the ball so that there was 0 degrees, or there was 0 degrees. It doesn't matter where this 0 degrees is, because it's symmetrical. So if we were to average it down, which won't be completely correct because it is not a triangle there, it does have a little bulge out. But anyway, that is the... So if we can take the average from there to there, we can take the average because it's a symmetrical ball. Anyway, so if you look at it that way, in 10 metres, the Earth's going to curve 6.3 metres down the x-axis out of 10 metres. I have a 10 metre pool in my backyard. The water's not full in the middle and curve 3 metres down on each end to being empty to follow the Earth's curve. And it just doesn't seem to make sense. The numbers don't add up. The numbers we are told, 8 inches in every mile, they don't add up. It doesn't make a ball. And so even if we got this number wrong, even if that was 80,000, we are still over... So that'll make this distance 20,000 kilometres because it's 80,000 kilometre circumference, doubling it. The Earth is just going to double these numbers. Or is it? Anyway, so there's a bit of maths for you to do yourself. How big would the Earth need to be to get 8 inches? How big a ball would it have to be to have 8 inches drop in every mile? It would have to be a very big ball. Because 8 inches drop in every mile, to use that right around the Earth, it just doesn't work, as I explained before. And this math doesn't seem to work either. But I mean, we should be seeing massive curvature. We should be seeing curvature. I should see curvature in my swimming pool. Anyway, it's something to think about. Dead flat. Not one sign of curve. Should be curving this way. And should be curving away from us. Should look like we're on a mountain of water. Curving away in all directions. I wonder why these stars are blacked out. I wonder. Pulled off pretty convincingly. Other than that, maybe the colours. I'm not sure about the colours, but you get all different colours depending on who's giving you the picture. Are they all pictures of the same thing, or are they all rendered by different people or drawn? 24 hours a day now you can get rendered pictures with no stars. Maybe they took this still frame while they were all twinkling. All of them at the exact same time, I'm not sure, but but other than that, it would be quite a convincing picture. It's amazing that they can't just put stars on it. They didn't think of it. Just fool us with the Earth. I'm not sure. Anyway, that's my thoughts. I'd love to hear yours. Leave a comment. Thanks for listening.